Good morning. Welcome back to our Economics of Regulation course. Even though it's early morning and we had a late game yesterday of the German national soccer team, there was not much reason to celebrate. They just made it and to the what is this, eighth final or something, round of the last 16th. And it was really almost an embarrassing match. Anyway, we move on with economics of regulation. Before we do that, I first just want you to ask to join me in Webex, and second, just to draw your attention once again to our seminar on competition and regulatory economics topics with respect to the COVID-19 pandemic. So you have the possibility to register for that seminar. So if you're interested, you can get further information on our websites, on our website. Okay. So I just want to start, as always. Just tell me if there are any problems in the YouTube chat. Okay. Welcome back to our Economics of Regulation course. Today we are going to discuss what Armstrong-Sappington called practical policies. The starting point here is that our complicated models we looked into when we discussed asymmetric information, in particular adverse selection and moral hazard, are quite difficult in order to apply them in the real world. In the real world, information asymmetries are hard to characterize. Richer models are hard to solve, that is, more realistic models. And of course, it's hard to specify all constraints on the regulator and the firm. As I mentioned already in the discussion of transfers, it might not be possible to pay some lump sum transfers or something like that. We discussed this issue of capture and whether the regulator is benevolent at all. And so what Armstrong and Sappington suggests to look into alternative approaches, to look for policies which are not precisely optimal in this Bayesian sense, but which somehow perform well in an average. And in a sense, that's what we already did when we discussed performance-based regulation at the beginning of Chapter 8 and what we call then also incentive regulation. And what I show you here is just a refresher of some slides I put up in that chapter. And the important point is what we will look into in some detail now is price cap regulation. Price cap regulation is interesting in the respect that it's really a high-powered incentive because you have a fixed price where typically, and I don't want to go through all the detail of these very full slide here. The point is that you really have high-powered incentives and you make, in a sense, the firm, the regulated firm, the so-called residual claimant of all, say, for instance, the cost savings they are able to achieve. Okay, and what we also discussed, and that's actually the final point we have here with the RPI minus X, this price cap mechanism is typically applied to some weighted average of the revenues of the firms, and we will go to discuss that in more detail in the next, say, 20 or so minutes. And what the problem is, what we already learned is that all these mechanisms are never poor in the real world. The price cap mechanism also applies elements of cost of service regulation. Remember, we had some A which was based, so you probably won't remember, but I perhaps might just jump back here. I think that's what we had here with these polar mechanisms. And I can jump to the point where we discussed this, how the regulation, how the contract looks like, where we have some A plus some B based on the cost and so on. That was our topic. So we always have some kind of other elements just want to have a pen here. So we have some high-powered price incentive. However, we have a ratchet. That's a topic we had with dynamics. That is, the point is that the regulator learns over time, and that, in a sense, lulls the incentive to invest in cost reduction. And you also have outside competition. You compare the cost level with other local monopolies. Okay, what we also see or saw actually that the regulator firm is sometimes allowed to look into or to determine the structure of prices, and we will discuss that in some detail. And that's what I already told you. The regulated firm is allowed to increase its price according to this famous RPI minus X formula. So we have some increase in the price level due to general inflation, and at the same time prices should decrease because of productivity changes and productivity increases. Okay, so that's another point here, what we have, and actually that's already something I already discussed. So setting this starting price level is very often not so complicated, because you just start with the price level you historically inherited. What is more complicated is the setting of this productivity factor X, and how long should the review period be. For instance, in German incentive regulation in gas and electricity, it's 5 years. Of course, some cost-based regulation is used to set the original level. At the end of this period, a new starting price is established. And we have this regulatory ratchet, that is, if you achieve a lower level by the end of the incentive regulation period, this 5-year period, this is just the starting point of the next period. So you don't start anew at the high cost level in 5 years ago, but at this new lower cost level. And so the problem is how to provide efficient incentives for cost reduction. At the same time, of course, you want to extract the rent, and you want to make sure that the firm survives, okay, is viable. And that's what we have here, this ratchet, Speerklinke in German. It just tells you, and I think I discussed that in some detail, it tells the regulated firm, if you achieve a cost reduction next year, you will have to also achieve that, or even more for cost reduction in the next but 1 year, in order to make some profits, okay? Yeah, I think so. Here there is some lengthy treatment of how the X, this productivity factor, is determined. This is from Josco, and he says that in US somehow it's some target rate of total factor productivity of the regulated firm and the economy of a whole, okay? And the difference between these rates determine then how quickly the prices should decrease if there were no inflation. So clearly the productivity rate is a different one in a postal service than in the telecom service, and in a computer industry it's also different. So you have to apply some specific values here. And what Josco here states, that in the US some historical values have been used, some empirical models to identify, or methods to identify, this cost efficiency frontier. And I think I just want to show you what the Bundesnetzagentur does, because that's freely available. I'm able to manage it here. This is freely available on the internet, where you see here they have an Excel tool. They use what is called a Turnquist index, and here in detail it's determined how they do. And this is really a very lengthy, and I have to make it smaller, a very lengthy process, where you see they have a huge slide where they have all kinds of input in order to determine this productivity index, okay? Of course, this is highly disputed, because whether it's 0.5 or 1%, that would mean that the prices have to go up or down by the respective percentage, okay? And of course, that's very, very complicated and important. Okay, so here you see, so this was pretty much our refresher, and just one short remark with respect to this determination of this productivity increase in Germany. There was just a recent decision of the Bundesgerichtshof, the German Supreme Court, on this, on the method how the Bundesnetzagentur, the Federal Network Agency, determined that. And the Bundesgerichtshof, the Supreme Court, confirmed this way how they did it. Actually, that was heavily disputed, and we had, as in our previous seminar in the winter term, for instance, Markus Söri here, who is with the Open Grid Europe pipeline company, which provides for distance gas pipelines. And of course, for them, it costs them dearly, okay? Anyway, so if you're interested in that, that's a rather somehow a tedious topic, because you have to go through all these cost accounting. But anyway, it's rather important for the companies. We move on here. It still moves on, but now we are getting closer to our topic here. So it's about the incentives to reduce both cost and quality, and we will discuss that in some detail in what is coming here, okay? And in particular, of course, the easiest way to reduce cost if you have a given price level is just to scale down quality, because that means that you, for instance, need fewer personnel and so on. and therefore these price mechanisms are increasingly accompanied by specific performance standards and the threat of regulatory penalties. Just think of if you want to switch your telecom provider, the companies have to make it possible that you can do it within 1 business day. Okay, and therefore these formal performance-based revenue performance-based regulation mechanisms, they set performance standards and specify penalties, okay, and rewards for the firm. Think of Deutsche Bahn or of some railway connection. They have some punctuality goals, and if they don't meet them, they have to pay some fine. Actually, I think the Rhein-Main-Verkehrsverbund, these public transport authorities here in the Rhine area, they pay you some damages if your train is late, I think. So they introduce something like that. Okay, so what we are doing here, and this is now actually the program for this section, after giving this very short reminder of what we discussed at the beginning of chapter 8 about price cap regulation, we also discussed rate of return regulation, and now we will compare that based on several other dimensions, and also doing that with what we've learned in our theoretical chapters. So what we discuss is we discuss how flexible firms are, or how much discretion they have when it comes to setting prices. Okay, what's their flexibility over relative prices, and what you will see that price cap regulation typically offers more freedom than rate of return regulation. We will look into what how sensitive the prices are to cost, and it's clear that price cap regulation is much less sensitive to cost than rate of return regulation. We look into the regulatory discretion over policy, and that's what you will see is that given that you have with price cap regulation always these 3 or 5 5-year regulatory periods, the regulator has a lot of discretion every 5 years to set quite new parameters. Okay, and finally, how does the incentive to provide quality look like? And I don't know, somewhere we will also have this incentives for investment. Okay, so this is just from Armstrong-Sapping table 1, where we compare it and where we show in more detail price cap regulation gives you a lot of flexibility over prices, and this will be our next topic. The regulatory lag with price cap regulation. So it's a 5-year period. So if you have some reduced some cost reduction today, you are left with that for 5 years in rate of return regulation. By the end of the year, you will be reimbursed if you have a cost increase, or you will get a reduction in your allowed or your asset base if you have a cost decrease. Okay, sensitivity of prices to realized cost, we discussed that. Regulatory discretion, that's always we discussed. So, and in the remainder of this chapter, we will discuss that in much more detail. Incentives for efficient cost reduction are strong under price cap regulation. At the same time, incentives for making durable sunk investment are limited. So, in a sense, this just summarizes the discussion which is to come. Okay, and that's why I just move on here. And the first point, what we will discuss is tariff flexibility. And here, this is in a sense the standard kind of price cap regulation. Okay, this is price cap policy. And here you have some end products. Think in terms of calls. That was about the first industry where it was applied in the UK, where you had local calls for distance calls, international calls, and so on. And you also have, of course, the access charge for getting a telephone at all. And so the interesting thing, or what we learned is in our discussion of asymmetric information, is that the firm typically is better informed about important parameters of the market, like consumer demand, than the regulator. And then it's desirable to offer the firm some flexibility. Okay, and here it's rather straightforward. If consumer welfare is our standards consumer surplus, and we have some firm profit function, and of course, again, private information means the firm has private cost information and so on. And if you have no flexibility, you just set a certain price vector P0. But and this is a standard. Hopefully, you remember that kind of. This is not even a revealed preference argument. What is straightforward? If you allow the regulated firm to charge any price vector which leads to a higher consumer surplus, of course, this improves welfare. Okay, so here's no problem to allow for flexibility if you, as a regulator, can guarantee that. Okay, and of course, you have a problem if you don't know consumer surplus, because the company can then tell you, okay, this new price vector leads to higher consumer surplus, but you just don't know. Okay, and you probably cannot ask 80 million or 40 million German households. Okay, okay, so how can this flexibility look like? First of all, we look into some general, actually this is some general properties of of demand functions and in particular of consumer surplus, or actually what is also indirect utility here. Here we just get an important fact. And we know then a lot about what price changes imply in terms of welfare changes. Okay, so what you see here is, what you see here is that prices are convex here prices are convex. The consumer surplus is convex in price, and that's what the important point is here. So suppose you start with some price vector P1. If you change then the price, how will that affect consumer surplus? Now, a straightforward thing is that if you increase one price, what is the maximum reduction in utility you can have? Yeah, this is just if you leave your consumption quantities unchanged, and then it just means this is just the increase in what you have to pay. Okay, so if the price increases from say 10 euro to 20 euro, and you have 10 units, your damage will be at most these 10 times 10. Okay, why is that the maximum damage? Because you can choose to substitute away. And that's what I try to illustrate here. Suppose you have several products which you consume, and one price 5, increases. So previously it was this level here, okay, and we had this welfare. And actually, if you take a derivative of the consumer surplus with respect to the price, you know the derivative of V with respect to P1 is nothing else than minus Q1. Okay, that's what you have, and this is actually what is written here and here. Okay, and the point is what you have here in terms of this difference is nothing else than what is written here. Okay, this is this change in the price level, and in a sense, by applying this, you nothing else get an estimate of the change in your utility. However, you overestimate the decrease. If you have an increase in price, you overestimate the decrease in the level because you typically substitute away, and that's where this convexity comes from. Okay, so the indirect utility decreases in price, but at a decreasing rate. Okay, the decrease gets always smaller. Should be clear, hopefully, right now, so that you get this shape. Okay, you can always substitute away. And from this kind of simple diagram, this follows immediately because you're never hurt by a price change as much as this changes. Okay, give it from the starting point as much as it would cost you if you just leave your consumption unchanged. And we will use that here. And the first argument, and this is a rather general and abstract argument, is some argument on average revenue regulation right now. What is average revenue regulation, by the way? We have to first define that. So the idea is, suppose you start with a telecom company, which charges some 10 cents for local calls and 20 cents for distance calls. So if you have the same number of call minutes, this would be the same as, say, 15 cents per call on average. And what you have here is, suppose you have an average call price of 10 cents, you are allowed to choose any combination of prices so that the new revenue divided by the quantity is just this price. Okay, this average price, and this should be rather clear. Of course, this requires that it makes sense to sum up these quantities. That makes sense if you think about call minutes. Okay, you can easily think about calls, but of course, it doesn't make sense if you compare apples and oranges. So, and what you see here, this average revenue regulation would allow you any kind of price changes which give you a revenue which divided by the quantity gives this. Per call minutes. So if previously the price per call on average was 10 cents, so then you can change prices at your revenue divided by the new number is also 10 cents. Should be clear, and we will have examples on that. So the permitted level of average revenue. And if this constraint binds, actually we can immediately show, and this is rather involved somehow, of course, that the consumers are worse off compared to uniform price. Okay, the important point is here you see this P is already in a sense the new level, but here the P is the one we need here. Wherefore we have this P here and the V P prime Here, of course, because what is determined here are these quantities. Okay, and that's why we have this here. So we can put that in this relation. And so our starting point is in a sense the new price level. We know then this is the quantities, and what we can now look into, how would consumer surplus change if we move from the new price level to this average price level. And of course, we know this is consumer surplus with the new level. This is the change here we have then. And what you see here immediately, of course, as this is on the right-hand side, we know the left-hand side is higher. Yeah, I think this is, I don't know, is there, yeah. So this is what we have here. And why is it higher? What we know here is that this is 0. This is just our definition up here. Okay, this is just our definition up here. And this is 0. Therefore, we know that with the old prices, you would be better off. We will have several examples so that you can see that in much more detail here. The point is that this allows a firm to increase the price rather drastically. And that's what I try to illustrate here in terms. I just don't know whether this was really completely clear what I did here with this, hopefully you can hear me, with this last point about the average revenue regulation. So what I just wanted to highlight once again is that the really decisive point, if you compare this expression with this up here, is the Q. And the Q is a function of this P of the new prices. And you see, you always have to have the indirect utility, the consumer surplus here on this right-hand side has to be the same as the price vector you have here. Oh no, I don't know whether this helped, but I tried. If there are any questions, we might discuss that later on in Webex or either or otherwise in the lecture of these diagrams. Okay, and I don't know whether it helps you a lot, but at least I like to introduce these nice diagrams and these nice utility, IC utility curves, IC expenditure curves, and so on. Here I use, and that's what you can write in the notes, a standard linear quadratic utility function, and with certain parameters. A1 would be 90, so that's just our product 1 is in a sense the more elastic one, product 2 is the less elastic one. We have substitutes. Remember, this was our standard kind of demand function here. And in our starting point, I just assume that the price levels were 25. And this price level, or what is written here, is this IC utility curve with the consumer surplus. And first of all, we probably have to know or to illustrate or to explain what this IC utility curve means. First of all, this should remind you of indifference curves. However, indifference curves are typically put into the quantity space. You would have Q1 and Q2 here, but this is now a curve in utilities or in price space, and this gives you the IC utility. And of course, what is clear, in which direction does utility increase? It should be clear. You are best off if the prices are 0. So utility increases in this direction. Okay, utility or consumer surplus. Of course, if you get this in a sense for say 15 rather than 25, you will have higher utility. Okay, so the IC utility curves with higher levels are closer to the origin. And the second point is now, why do we have this standard slope in a sense? What is always clear is that we should have a negatively inclined utility. So the point is, if you increase or if you decrease one price, your utility will go up. In order to keep it constant, you will have to increase the other price. Okay, that's straightforward. And why is this convex shape here? That's interesting. Here the point is, in a sense, it's just with the indifference curves. I always tell first-year students averages are better than extremes. Here it's just the opposite. Extremes are better than averages in a sense. They give you higher utility. Of course, here if you just draw some convex combinations, you'll see that all points, if you have one half of that price and one half of that price, you would be worse off. Probably I should use a different color here. You would be worse off. Why is that? Yeah, because it gives, in a sense, you fewer possibilities to substitute. Okay, and actually, and I think I really should choose a different color because it gets hopefully clearer. actually we would have just horizontal lines here and here. And why is that so? Now, so given you have some other price, some price P2, from this price on, actually demand would be 0 for for one of the products. Okay, and of course, if the demand is already 0, your utility does not further decrease. Okay, if you increase the price, and the same holds, of course, if you go up here. Oh, I have problems to draw straight lines here. Okay. Yeah, and that's how we come up with all this shape here. Okay, and finally, what is the slope of this diagram? And I think I wrote that somewhere also in the notes, but just to make it clear, you can derive the slope by just applying this standard. Oops, I have dp2 over dp1 standard implicit function theory. Okay, this would be just dp2 would be just dvp dp1 over dvp dp2. Okay, and that's what you just learned. Hopefully, I even did that in my Micro 1 course in Econ 101. Okay, so that's how I derived the marginal rate of substitution. That's how you derive that. And of course, here we know that. Now I use again the color here. What we know is that this is nothing else here than minus q1. And this is nothing else than minus q2. So your slope is just here a q1 over q2. Okay, and ISO expenditure curve is again nothing else than E times, E is equal P1 times Q1 plus P2 times Q2. Okay, and so the slope is again the same expression here, because now it's not, remember in simple income or simple consumer diagrams where you have indifference curves, you would have the budget line here, and the slope would be P1 over P2. Here it's just Q1 over Q2. Okay, apart from that, these ISO expenditure curves gives you the different combinations of price 1 and price 2, so that you have some given expenditure given these levels Q1 and Q2. Okay, so why I'm doing all this? Because then we can illustrate and further develop further curves here. Then we can illustrate what average revenue regulation means in terms of utility of consumer welfare. And this again is another curve, ISO average revenue curve. This is another very strange curve. Of course, you have a certain average if you start at P1, P2 equal to 25. And now, of course, again, Econ 101. If you draw here, for instance, something like here you draw revenue, here you draw price or quantity, doesn't matter. What is clear, if you have a linear demand, revenue, probably I better put it in terms of prices because it's clearer. If you have a price of 0, your revenue will be 0. If you have a very high price equal to A, the cutoff price, your revenue will also be 0. And so, it's just such a hump-shaped curve, okay? And you know, suppose you start here with something like 25. Here with something like 25 and a certain revenue, okay, and a certain revenue. Of course, you can also say 75. It's not 70. It's even 75. You can have another price and higher price as well, which gives you the same revenue. And this is exactly what shows you here. And the point is here, you just can play around as a company. If you increase one price, depending on whether you're an elastic part of the demand or an inelastic part, this increases or decreases the price, which why you get here a decreasing and an increasing part. Okay, just depending on whether you're in the increasing or decreasing part. And this is nothing else than just the curve which follows from this condition here. This follows from this condition here. Okay, you just or I just plotted this condition here. Okay, then of course we want to maximize profit. We want to choose this bundle where you this combination of prices where you have the maximum profit, and that's why I introduced another curve. You see many curves here. This would be the ISO profit curve, simply defined as, I think I assumed that marginal costs are 0 and profit is simply here in this case pi is just P1 Q1. Of course, Q1 is a function of P1 here and of P2 as well. So of P plus P2 Q2. And you just start with a given level pi upper bar and get then this curve. Okay. Of course, if you have this will go down as well. This profit. Of course, here profit is increasing in this direction until you have some profit maximum, and this would be just the monopoly prices. Okay, that's why it actually would look like something like this. It's, however, just hard to draw with some program here. Okay, now the problem is here you don't see so much, and what I want to show you is that given you have this constraint, these ISO average revenue curve as a constraint, and you're allowed to move away from these prices P1 and P2 equal to 25, you have an incentive to change the price, of course, in order to increase your profit. And these incentives, however, is bad in that sense that, I don't know, I probably tried to use the laser pointer here. So this was the original, prices with this red line as a utility, as a consumer welfare or a consumer surplus, and this blue line here as the ISO average revenue curve, which is here but has also is tangent here in this point, but has a deeper slope here than the curve. You can immediately derive it. I don't want to do that here. But the point is here, this is your constraint here, this blue curve. Okay, so you would choose an ISO profit curve which is tangent to this blue line and which is as far as possible away from the origin. So, and what you see is actually this is this price here. And of course, you just can calculate that. The important thing is that it's further away from the origin than the original consumer surplus, the original ISO profit line, ISO utility line. Okay, and so that's what you see here. You change prices in a way as a regulated firm, which makes consumers worse off. And in a sense, you you have here a price change for these two products. And the price increase, here price increase for elastic good decreases revenue. So yeah, here it's always very complicated to argue with elasticities, because elasticities with these linear curves change so much, and you see here is a very strong change compared to the original situation. Because I think in a sense, product one was the more realistic, the more elastic one, but here the price is lower, so it's always rather complicated here. But anyway, so what you can do here is to calculate that with average revenue regulation. Okay, hopefully this is clear. We will have an assignment or in a problem in assignment on that, so it should become hopefully clearer. Okay, I just want to make a short break here and ask in Webex whether this was clear, whether you liked my nice diagrams and curves as much as I, and whether, or perhaps they confused you. Okay, we move on here. What we do just here is just another instance of this average revenue regulation, where we have two-pot pricing, and this is something like what typically applies with your water bill, your electricity bill. You have some fixed monthly charge A and some per usage charge P with per consumer demand Q, and so average revenue regulation would mean, so you pay say 1,000 euro a year in terms of average of excess charge, and you have say a per liter or per cubic meter price of 5 euro. Given your consumption, this gives a price you pay per cubic meter, and this would you can just then change P and A in a way so that your average price per cubic meter is not higher than something. So actually, that's what I'm going to show you, or what we are going to discuss in if I manage to get to it. What we will discuss in an assignment, where I just took data from my water bill, and where you will just calculate what average and what average regulation means, and what tariff basket regulation means, to which we turn next. Okay, so you will see it's rather straightforward to calculate that, and yeah. So given we have, so hopefully it's clear. So you have this average monthly. So we have this average monthly charge and the per unit price, and you're just dividing your total payment by the quantity gives you what you pay on average, and here this is just a constraint. And if you have this constraint, you can just solve for A, and if you put that into your profit function, A here, just as always, price minus cost, so per unit profit times output, and if you put that here, you see your profit, your per unit profit is independent of your price, and you can increase your out of your profit by increasing the quantity, that is by reducing the price. So the optimum is that you choose a price as low as possible. In terms of water, just charge a price of 0. You cannot charge negative prices because you run into trouble then, because people just will open their tap, okay? But you get a highly inefficient outcome as price will be below marginal cost, okay? And that's what we will see. Unless if you have that some people no longer demand water if you have a very high, actually, of course, everyone needs a water, but in some Bavarian villages, people would just start building their own wells, okay, and getting their own private water. Okay, that's...
Okay, before I move on, I'm going to tell you that this is really my water bill. Here you see, this is really my water bill. Here you see the Grundgebühr, so the monthly fixed fee, which is something like 50 euro. And here you see that you have for wastewater and for fresh water. Okay. And if you see these numbers, you will see, even though I changed them slightly, this is exactly what we have. So the per cubic meter, here you see this m raised to the power of 3. The per cubic meter price is about these 4 euros. Okay, hopefully this convinces you that this is really a relevant task. Actually, I think they are about to change the water price anyway in the near future. Okay,
that's what should become very clear in this problem. Yeah, now average revenue regulation is not a good idea. Nevertheless, we discussed it at some detail here because this has been applied by many regulators. Actually, German electricity regulation and gas regulation is also network regulation is also an average revenue regulation because you have these fixed revenue, okay, in a sense. But you will see it's not a problem here because with electricity and gas pipeline networks, the marginal cost in particular with electricity is 0, and therefore you don't have an incentive to increase the price very much. Okay, tariff basket regulation. What does this mean? And this hopefully should you remind of Lasper immediately. So tariff basket regulation means you can charge any price vector which allows you, this were in the original situation, your expenditure given this old price vector. And you are allowed to charge any price vector which, given the old quantities, applied the new prices are affordable or provide or lead to lower expenditure than the old prices. Okay, and this is just a standard Lasper policy in a sense. And so P0 would be the reference price sector. So here, at original prices, you consume this quantity times or weighted by the prices. This gives you this expenditure, and applying the new prices to the old quantities leads to this expenditure, and that has to be lower. And from standard reveal preference argument, that means just you can afford the old bundle. Okay, you can afford the old bundle, therefore you have to be better off. And you can show that from what we derived up there, but it's obviously clear. And of course, the firm will always be better off, at least it's not worse off, because it can change prices. Of course, we have to know the demands at hypothetical prices, but this is not a problem if we look into a dynamic version, because in a dynamic version, we are in a world that it is right now, we have some prices inherited, okay? And so in time equal, so if we are in period 1 now, we know what prices were in period 0 and what quantities were in period 0, okay? And so you have an initial price vector. And what you see here is if demand is stable, does not change, consumer surplus will rise over time. And again, this and even converges to some kind of Ramsey style prices where, however, Ramsey style, remember this was this break-even constraint, but here you have a rent firms make a profit. And again, now it gets even more complicated. What I have here, or perhaps I should jump back, what is now, I think it's much easier if I jump back to our very initial diagram here. Now, what is the constraint the firm faces right now? It can charge any price combination here, P1, P2, which if we apply the old quantities leads to an expenditure which is not higher than 2,500. Okay, so that is actually, of course, it will always just use up or just set prices that is equality satisfied. Otherwise, it could increase prices and therefore profit. But the point is that this ISO expenditure curve is just now the constraint for our firm. And of course, as our consumer surface, our ISO utility curve is just tangent to that curve, each other point we choose, each other point the firm chooses will lead to higher utility. Okay, and that's a nice thing. That's why this tariff basket regulation is such a nice thing. It's clear that consumers must be better off, and that's I have to admit that this is really, if you look at it in the first time, even if I try to increase it, it will be very complicated. So our starting point was this point here with P1 and P225. You see that the ISO expenditure curve here is our constraint. We have originally this ISO profit curve giving you profits of 2,500. Okay, these cuts here, so you get, in terms of our, if you were discussing consumer theory, we would speak of a lens here. Okay, and of course, I didn't draw the next ISO profit line. You see, you cannot achieve the ISO profit line you had in average revenue regulation, but anyway, you can achieve an ISO profit line. I don't know whether I can even draw here. No, I can't. An ISO profit line where the optimal, which would be tangent here in this point here, and here you get the optimum prices, and what you get here is you increase your profit, okay? And consumers are better off. And of course, in a dynamic version, then this would be your new starting point, and you can adjust again, okay? And in the end, you might end up at something like Ramsey prices. Okay. This was this first part. I think I make a short break here, and before I move on to the Vogelsang-Finsinger mechanism, where it's about eliminating rents, I make a short break here and ask for any questions here. Okay. Also share break here and ask for questions in Webex. Yeah, okay. We had some discussion about these diagram here with this ISO profit curve, I think, of 253. What is the tangent point here? Actually, this ISO profit curve here is tangent to what we have on this curve, is tangent to the ISO average revenue curve. And the ISO average revenue curve is quite a single thing. If you think in terms of this telecom regulation, it's just say this piece bar would be just 25 cents. So you can charge an average price per call minute of 25 cents. That means you might charge 50 cents for some local calls and 0 cents for distance calls if the quantities are accordingly. Okay, anyway, so this is the constraint here. Hopefully it is clear. I think if not, just ask further. We discussed that in Webex, and you might just ask then further questions as well in the tutorial class. Okay, we move on with the stream here and with the Vogelsang-Finsinger mechanism. Back again. Yeah, I think it should become clear, all these discussions, once we apply them to examples. I don't know whether these diagrams are really helpful. I just like them. That's why I show them to you. And once you go through them, you hopefully also see the pretty of these diagrams. Now, the next point is what a regulator might not want or like is that all these tariff basket regulation, of course, and this kind of price cap regulation gives firms a rent. Okay, because they start with some historical expenditure. And actually, these historical expenditure typically were high because firms didn't invest a lot in cost cutting and didn't work hard to achieve lower costs. And then you apply these price cap regulation, and it turns out, oh, they could easily reduce cost and therefore earned high rents. And what these two Ingos here, Ingo Vogelsang and Ingo Finsinger, suggested sometimes, I don't know, in the 70s, 80s, is that you could have a mechanism, such a dynamic mechanism, which reduces this rent. And how does that look like? Actually, it's almost the same policy as we just discussed. Okay, you can charge any price vector so that you can still afford the old bundle. Okay, the only difference is now, okay, you observed that last year they made 100 million euros of excess profits. And so that is, you tell them, okay, last year the expenditure was 10 billion and you had excess excess profit of 1 billion, say, and now this year you have to achieve that the price of the expenditure on the old bundle, given the new prices, is just what the expenditure was last year minus your excess profit, and this is what gives your allowed, in a sense, expenditure or revenue. Okay, that should be rather clear cut. Same thing as previously, just with some deduction here, which is based on a profit. And you start from some initial price vector. And again, if the firm is myopic, that is just doesn't think ahead, and you will see that in a minute, and also in our next assignment, you would get convergence to Ramsey prices. The problem is here that this is in a sense cost plus regulation, and you would have poor incentives for cost control when firm is forward looking, and that's what I illustrate here on the next slide. Okay, we make the life simple here in this. Oh, where's my diagram is only in the next on the next page here. Suppose we have only a single product firm and has some observed unit cost CT. That's very similar to our setup of the yardstick model by Antje Schleifer. And the firm can choose any cost CT greater than some C, which is the true cost or the optimal cost. Okay, this is actual cost and not just misreported. Okay, and what you will see here, of course, discounted profits, or just here some discount factor delta, some quantity in each period, and of course price minus marginal cost would you give the operating profit we abstract here from something like fixed cost. And this Vogelsang-Finsinger VF regulation implies that the price in period 1 is equal to the cost in period 0, okay, with some initial price level. And the point is, if the firm operates efficiently, see, it would have a certain profit, C0, but if actually you will see the price will be set equal to that profit anyway. But if the firm pads, that's how it's called in English, pads its cost, so that it somehow manipulates its cost that it's higher, and it operates efficiently later, it gets a higher profit. Okay, here, because the price will be set in a dynamic way, you have some. Okay, that's if you directly operate efficiently, and if you pad your costs, you will have for one period this profit, and for the other period you will have this profit, and this has to be discounted. I think it's always much easier to look into that in terms of a diagram, and that's what I mentioned here. Okay, now just to illustrate that, here you have your Q. Originally you have this price, and this gives rise to this quantity. Okay, and what you can do is to choose any cost level between P0 and C. And now you live 2 periods. The question is, which cost level would you choose? Now, yeah, the first thing, hopefully that is this, if you immediately choose the optimal cost level, in a sense the real one you can achieve, your profit in the first period will be that. Okay. And of course, your profit from the second period on will be 0, because price will be set equal to your marginal cost. Remember, this was just the point where this yellow area is just withdrawn from your allowed revenue. Okay. And now the question is, can you do better than that, knowing this policy? Now that's what you see here. If you first only reduce your cost to C0, you will get in the first period this green rectangle. Okay. And in the second period, however, you start with this lower price, therefore you will have a higher quantity. And if you then move on to the lower level, you get the larger green rectangle here. And of course, in total, these 2 rectangles are larger than this one. And of course, now it just depends on your delta. If delta is 1, it's obvious that it's better. If delta is lower than 1, it depends on how low delta is, whether it's optimal to change that. Okay, but in a certain way it will always be optimal. Here you see the formal proof. I don't want to go through it because I think it's so obvious from the diagram. Okay, that it's always optimal then to pad the cost. So given that you have some delta which is not too small. Okay, if delta is too small, then it doesn't help you. Then you want to, if you know you are bankrupt anyway next year, you want to make as much profit this year as possible. Okay, but apart from this situation, you always have an incentive to pad costs. That's what was meant by this point that is cost plus regulation. And actually, again, I think even in the assignment for next Tuesday, we will have just such a situation where you need to calculate that. And here, with myopic optimization, would mean that you do not take into account that in the next period you have a price according to your own cost. Okay. And therefore you just would say, okay, here if I'm able to reduce my cost, I make a profit, and I don't look into the future and knowing that I don't make any profit next period. Okay, that's the Vogelsang-Finsinger. So the problem is here that if firms are sophisticated, you have trouble because they have an incentive to cost padding, and then of course always David Sepping comes up with some offer to the rescue and shows how you can change this mechanism so that it's in a sense incentive compatible, that the firm has an incentive to choose the true cost. And the starting point, however, is a quite ambitious one or restrictive one. You have to know consumer surplus and consumer demand and consumer surplus in detail. Okay, some operating profit. And now, so this looks rather complicated. You get paid this period just the increase in consumer surplus. What I again from the perspective here, you gain something in this period and have to pay it back next period. I think I rather than showing you that in detail. So if you reduce the price, okay, if you reduce the price, you get paid the increase in consumer surplus minus, of course, and that's a Vogelsang-Finsinger part, minus your profit you made in the previous period. Okay. But if you start in a situation, here again, our diagram, if you start in a situation like Vogelsang-Finsinger, and then this profit in the previous period would be 0, then the point is, what do you get if you are able to reduce your price from some level P0 to a lower level? If you reduce it to C0, you get paid in the first period just the increase in consumer surplus. And the increase in consumer surplus is now nothing else than these yellow trapezoid, or however that's called. Okay, that's your increase in consumer surplus. That's what you get paid in the next period, in the first period, of course. In the next period, it's again taxed away. So you only get that for one period, because then your costs will go down to 0, or your price will go down to 0 just by the fact that you have to pay this in terms, this yellow area in terms of taxes in period 2 then, okay? But the question is, do you have an incentive for cost padding? Do you have an incentive in the first period to choose something like CH? And now what would you get if you choose CH? You get in the first period that, and in the second period, you get exactly that here. So you get on aggregate the same, however, you have to discount that, okay? So it's clear that as soon as if delta is smaller than 1, its cost padding is not optimal, okay? And this is due to the fact that you have just now the consumer surplus. And you realize immediately if you have this C, you realize immediately the whole increase in consumer surplus. Okay, so the important point is you set price equal to C in the first period, get paid actually the whole yellow triangle, and that's what gives rise to this policy. And this is in a sense a dynamic version of this Lopen-Maggart model where consumers obtain all gains from trade after 2 periods, but you as a firm get all the gains from trade in period 1. Okay. And this is what at some length is written here in formal terms, but that's I think we have I don't know if we have it in the assignment as well, should be clear here. The point is you always just get paid, or it always depends on the delta, how much you get. Okay, and that should be clear from these diagrams, rather than going through the details. Yeah, next.
Okay, I just want you to show that here really in the next assignment we actually have here this last part is nothing else than Vogelsang-Finsinger, where you have a firm whose price who the regulator sets. I don't know whether you can see this here. The price the regulator sets depends on its own marginal cost in the previous period, and so you will see what happens here, and you can calculate the numbers. Here it has 2 stars, not because it's so terribly complicated, but it's hard to solve just by paper and pencil. So you would have to use some I don't know, not Mathematica, but some more sophisticated device. Okay, we move on here with tariff flexibility.
point here, a very brief point here, tariff flexibility and entry. What is rather interesting, suppose here you have, I don't know which example I should make. Probably I best take the one Armstrong and Sappington use. BT is British Telecom's response to Mercury's entry in long distance telecom. So for instance, in the United Kingdom, firms until the early 1980s, British Telecom was a monopolist and no one could enter. Then entry was allowed to a single company, Mercury, and in long-distance telephony. Okay, the point is that at that time, British Telecom was subject to some average price regulation, some tariff basket regulation. And what British Telecom had, they had some captive market. Namely, that the market for local calls, you couldn't go to Mercury to have a local call, and there was therefore no threat of entering that market, and there was only the threat of entering the long distance market. Okay, the point is actually if you're regulated in a way that you just regulated to some average price, so you're allowed to charge 10 pence per minute on average, what you might want to do is to reduce the price in the segment where you face competition. Okay, you just reduce that here. And of course, this allows you to increase price in the captive segment. You charge 20 cents or 15 cents in the captive segment for local calls and charge only 5 cents for far distance calls, long distance calls. Okay, that's in a sense what always people say or make with respect to say Deutsche Bahn. Okay, if they face competition in one part, they reduce the price there and increase the price in say captive parts. Okay, that's what you have. Also, Deutsche Post faces that. They have captive segments, they have other segments, and it's always the question of something like cross subsidization. But the point is here actually, and you always have to take that into account as a regulator. If you face entry and if you allow for tariff flexibility and the firm, the incumbent regulated company has a captive market, there's always the problem that these firms might distort prices in a way so to prevent entry. Okay, should be rather clear, and we will get back to that anyway to the related part. Prices, I now just have to check how much time I have because I didn't want to go too much into detail with respect. I didn't want to go to this slide. This is now actually responsiveness of price to cost in a world without transfer. This is just another actually application of our moral hazard model we had 2 chapters ago, and this would be just a further case, a further example of our general results where we have a risk neutral firms, but now the regulator, remember up there, very often in the real world, regulators cannot pay transfers. So we don't have, or we are not able to pay transfers. And if we have risk neutrality, utility is just easy equal to the rent, and the rent is equal to the profit. And of course, if we are in a world without transfers, there is no T here because we don't pay any. And this is very much just the solution we had up there. I don't want to go through the details here. I think it is rather tedious and it's not so much different. What is interesting here is that Armstrong and Sappington use some specific demand function here, and that's actually what we derived up there, or actually what we can derive here if we have v prime of u. You see this gives a complicated thing here, but actually v prime of u, remember this was just vp minus u, but u is just r, and r is just pi here. So what we have here is vp minus pi of p. Okay, and if we take the derivative with respect to u, what we had here is then nothing else than dvp dp, which would be minus q, and du dp is, and that's actually what we need here, and what I should have said before, we have to guarantee the participation constraint here. We cannot pay a transfer, and if there are fixed costs, that means we have to pay a price above marginal cost. And what this determines here, the du dp, is if you have, in a sense, higher fixed cost, if you need a higher rent or something like that, you have to have a higher price. And this is what gives you in terms how profit or how profit changes with a change in price. Okay, that's what you have here. And I don't want to go through the details here. in a sense, it applies just what we had and what we already discussed, because this is just, if we jump back, this is exactly what we derived in terms of the full information policy. The only difference here is now, and this is an interesting difference, if we cannot pay, up there it was clear you just pay the transfer equal to in a sense, either the fixed cost or remember our D of phi, our disutility from effort. And now you have to pay that via a markup. And what you see is that you in this model, you get the same markup. You get the same markup for both situations. Okay, and that should remind you of Ramsey prices, and that's what you get here. You get the same proportional relationship between prices and cost. This is actually cost plus regulation. You get Ramsey prices, but you get rather poor incentives, because irrespective of your cost, you get this high markup. And of course, that's especially bad if eta is smaller than 1, because you get then a very high and even a higher profit you would have if you have high cost. Okay, and again, this also looks terrible, but this is nothing else, and that's why I jump back here. What we did here, this just applies what we had here. You see here are your VUs, V prime U's, and that's the first order condition we calculated there. Okay, and here they are just applied with all we had here in this previous slide, where we derived this relation here. Okay, where we derived this relation. And that's it's just tedious, and I just want to show you what the outcome is, or to tell you briefly. And actually, the outcome is very similar to what we already discussed. Of course, if the firm by its effort cannot affect the probability, you get pure cost plus regulation. If demand is perfectly inelastic, you get a pure price cap regulation, because one can show that here, and in general you get that you are paid a higher markup if low costs come up rather than high cost. And the point is here, you now have the problem productive efficiency. You want to ensure that this firm provides effort, but at the same time, if you want to provide effort, you have to do it by distorting the prices, and you run into trouble with allocative efficiency. And so you see you have this trade-off. The point I want to take you away from this part here is just not the formal details, but these general kind of conclusions. Okay. Yeah. Now we have some more things to discuss here, and this is rather general. I think this is also part we discussed in some detail before: regulatory lag.
Okay, I don't know whether you need a short break here. I just make one. This was complicated, but actually it's. I won't, or we won't ask you in the exam for any formal details in that respect. So I'll just make a short break here to ask for further questions. Okay, we move on.
That's what we discussed with Josco. Of course, if you have some regulatory lag, this is something, or just look here, if you have a long lag, which provides you with good incentives for cost reduction, because that means if you reduce your cost right now, you can earn the benefits from that for the next 4 or 5 years. Okay, so the problem is, of course, we have poor allocative efficiency, because you would be able to reduce the price much further. Of course, with inelastic demand, if consumers don't change their quantities, if prices are lower, this allocative effect is not very important. If you have short lags, that's what we also discussed already, you have poor incentives for cost reduction. But of course, so you don't work hard to reduce your cost, but at least you don't earn high rents. Remember this discussion where the cost of service regulation solves this adverse selection problem. You don't get these high rents, whereas it's bad with respect to the moral hazard problem, and vice versa. And this has relations with the optimal patent length. I think what is really interesting is how does that, and that's important part of the policy discussion right now, how is regulation related to the incentives to invest? And here you see we are talking actually, or what is investment after all? There are 2 kinds of investment. The first is this cost-reducing investment, which is just managerial effort. So in a sense, this is short-term investment here. And you know that price cap regulation is very good to encourage this kind of investment. So if you have price cap regulation, firms will cut costs a lot. But will they also invest in say, durable assets? Yeah, of course, it's clear if you invest in durable assets, that increases your cost. If you have a price cap, why should you make an investment after all? Okay, if it increases quality, but what does it help you to increase quality if you just have a fixed price? So the point is, typically these are observable, so the moral hazard problem is not so important in a sense, because you can observe whether they build a new transmission line or not, and therefore they can be part of a regulatory contract and will typically be involved to regulatory to rate of return regulation. Okay, and so the question is, and this is a very important question, just think of broadband internet coverage. Okay, how do we make it possible that, or how will we ensure that firms invest sufficiently, and whether they make investment for our transmission lines and so on. What we also saw, informational opportunism, is just what we discussed in our dynamics part of the extensions. That is, if you have this two-period problem and you learn in period 1 that it's a low-cost firm, you are opportunistic in a sense that you use as a regulator this information in the second period. Okay, so you get a problem here, as well as sunk costs. They give rise to the problem. In English they call it moving the goalpost, because you, in a sense, you're expropriated. You get, first of all, you liberalize and you say, okay, you can charge high prices, but then after a year they just think, oh, we want to have lower prices. Okay, and of course, typically firms will that take into account and rather not invest. They will invest too little. Okay, that's a problem. And so here, what Armstrong and Sappington suggest is that dynamics actually can be, which is the source of the problem, can also be part of the solution if both sides gradually build up trust, in a sense that firms gradually build up their investment. They don't do it at once. In a sense, they punish the regulator if they don't get a fair return, and at the same time, the regulator can prove also his or her reputation. Okay. Of course, the problem is always with commitment. The regulator might be myopic, regulator might be susceptible to capture and not maximize welfare. So it's really an important problem, and that's an important real-world problem as well in many industries. Okay, if you now build up as Deutsche Telekom fiber optical networks everywhere, will you be, and you're exempt from, say, from regulation for 2 years? What will happen after these 2 years? After all, the depreciation period of your fiber optical network is 50 years. Okay, so here you have a lot of problems. Yeah, so, and what you always see, and here's an interesting thing, that rate of return regulation is really better. You need a predictable and attractive rate of return in order to give incentives to invest. Okay, with price cap regulation, the commitment is typically very much limited to, say, 5 years, and with rate of return regulation, you typically have longer commitment periods. Okay, so given our whole discussion about how bad rate of return regulation actually is, you might really be surprised to see such a statement, which is taken from Armstrong and Sappington. Perhaps rate of return works better than price cap regulation, okay, for this certain kind of investment. This is really, really interesting, because you somehow switch back. Of course, there is a discussion whether we could somehow rescue price cap regulation by having, for instance, longer regulation periods, like in the water industry. But the problem is, if you have these long periods, the regulation might not be credible, because it might turn out that these firms are hugely profitable because costs are actually lower, or so that prices could be much lower, or the price cap was too low and they run into bankruptcy. Okay, so in a sense, rate of return is easy as a basis for long-term policy. Okay, and in Germany, actually, if you want to make investments in the transmission lines, in electricity transmission lines, you typically have to apply for investment budgets, and where the regulator looks into an investment and then approves it in a certain way, and then you get paid here. Okay, and so of course that's already what I told you. You have to apply for an investment budget. You just cannot go ahead and say, okay, I just want to build these connections. No one needs it, but I build it because then I will get refunded it. No, typically, at least in Germany, the regulators typically use whether these investments are really used and useful. Okay, in German it says Bundesnetzagentur betriebsnotwendige Kosten. So is this really a necessary asset? Okay. Of course, then you have a problem again in terms of predictability. But here, that's why you have in Germany these investment budgets, and you have to apply for these projects. Okay, upfront, of course, that means you have a certain bureaucracy anyway, but somehow it's inevitable. Of course, there are with these issues of long-term commitment and credibility, of course, there are several institutional issues. Should we have independent regulators? Should our regulators be elected or appointed officials, meaning elected? Should they be politicians or should they be civil servants in a sense? Okay, the problem is here, of course, that politicians might think, oh, it would be good to have much lower electricity prices, so we just change our regulatory compact and say the electricity excess charges are lower. Okay, so therefore it might be in terms of commitment very important and also be wise to have independence of regulators and perhaps have not elected officials, that is politicians, but appointed officials. Okay, of course they still depend on politicians, but they might have more independence. We have a similar discussion in terms of the European Central Bank. Of course, regulators cannot be excessively independent. That's also the discussion currently we have in terms of the ECB, the European Central Bank. So there needs always to be checks and balances. Okay, should be clear. But this is in a sense here what we have in real world discussion, and hopefully our theoretical discussion. Or you have that in mind, and because this theoretical discussion, in a sense, provides the examples and the arguments why these are all problems. And here, the regulatory capture is something we also discussed. Okay, interestingly, former Chancellor Schröder was yesterday in German Parliament arguing for counter sanctions against the US if they install sanctions because of Nord Stream 2. Okay, the problem is that Chancellor Schröder is on the board of Nord Stream 2 of these pipeline networks. So it's not so clear whether he really does that in order to maximize German welfare or his own private welfare. Okay, so here we always have a constitution. The problem is, for instance, can we, in a sense, bribe our regulators as politicians and give the regulator a monetary incentive to act in public interest? I don't know about that. You might do that with the mechanics in Mexico. I gave you this example. If they or with the Indian inspectors of environmental or of the plants, whether they satisfy the environmental rules in terms of emissions, but it's really hard to formulate such contracts. Okay, typically you would specify broad regulatory objects and instruments. Even though, however, once in a while these rules, these laws are really rather detailed. Okay, and what is also an argument, you might wonder why all the time we discuss this issue whether transfers are possible or not. So why should you not always allow the regulator to pay transfers if you saw that your welfare is always higher if you pay transfer? The point is here that if you have capture, it might be a bad thing. And so it might be good to, in a sense, forbid some actions which might be in the interest of the firm, just like receiving high subsidies. You just forbid them, even though you know they could do something good. If the problem that they do something bad or that they are abused is too high, or if the possibility is too high, it's better to forbid them at all. Okay, so that's what's stated here. Regulating quality, I think these are now about almost the last few slides we have. Yes. Quality is an interesting aspect, of course. If you just think in terms of telecom, if you read I used to read some US crime novels, and therefore the culprit, not in terms of the crimes, but in terms of good service, was always the cable TV company. Okay, you never got reliable quality, and if you had a problem, it took you ages to get the cable TV mechanic. Okay, so what should be the quality? In these network industries. So the point is some aspects of quality to do with level of physical investment, network reliability in telecoms, risk of power cuts in electricity. Actually, that would be an interesting thing. How many minutes of average blackout do you think do German households face in each year? Compared, for instance, to the UK, I think in Germany it's at most 15 minutes a year. Okay, in the UK it's I don't know, more like 2 hours, I think, and in the US with their overland cables it's much higher. And the question is, of course, what is the right quality level? I think the German Bundesnetzagentur, they even tried to find out, they run surveys and asked consumers what their willingness to pay for this quality dimension of power cuts is. Okay, how much would they be willing to pay if their outage, expected outage is not 15 minutes, sondern 14? Do you have any idea? Okay, do you care for whether it's 15 minutes? Probably you will care if you are in a sensible business, then it might be very important that you never have an outage, so you will have generators and so on. But of course, in a sense, it depends how redundant your system is. Network reliability in times of the corona pandemic, the German system turned out to be rather resilient and reliable in telecoms because we have some redundancy. So we have too many cables in a sense. But that might be a good thing because it increases reliability. At the same time, however, it also reduces cost. Okay, but of course you might encourage that.
It increases cost. So if you have more cables, of course it increases cost. That should be clear. So you could reduce costs by having less redundancy and a less reliable network.
I think in terms of our masks we didn't have in Germany, it would have been good to have some overinvestment there. Okay, and of course you have to pay for that, for instance, by rate of return regulation. Okay, other aspects to do with current spending, that's switching. How long does it take if you want to switch your mobile phone provider or your fixed network provider? Okay, that depends on how many mechanics they have and so on. And you see, I think in Germany, if Deutsche Telekom takes more than business days to migrate your connection to another company, they have to pay some several hundred euros of fine. Okay, that's what you have. That's how regulators try to guarantee that even though we have some price cap, we don't get into trouble in terms of quality degradation. Okay. Yeah, regulating quality. So here I just want to show you briefly why quality is underprovided with price cap regulation. Just to assume that your profit depends both on price and quality, and also consumer surplus depends on price and quality. Now, if the price of the firm is regulated and firm can only choose quality, of course it will choose some quality level, because if it provides zero quality, no one, for instance, will use a Deutsche Bahn. Okay, so there is some optimal quality level determined by this here, but of course the socially optimal quality level would, in a simplified way, suppose alpha is equal to 1, would be just total surplus pi plus v, and I think I added just this diagram here. If you take then a derivative with respect to q, what a social planner would be, you see you just get a derivative with respect to pi. That's what we have here, which is 0, and of course at this value, and of course the consumer surplus would increase if quality increases. That's why this expression is positive. So at the privately chosen quality level, an increase in quality would increase total surplus. That's why we have under investment in quality, and of course that should be rather clear. If you have a price cap, it's always a good thing to have a low quality because you have lower cost. And how do you control this quality? Of course, what you might do is you might allow an explicit trade-off between price and quality, so that firms can charge a higher price if it improves the service quality. Of course, you need to know how the consumers trade that off. Think in terms of our electricity transmission operator charges a higher price because you get a lower blackout risk. Okay, that's rather hard here. I don't know. So this is really complicated in a sense to provide this this company with some tariff flexibility, that if they raise quality, they can charge a higher price. So how might you think about that in terms of punctuality of Deutsche Bahn, for instance? Okay, very, very complicated. So that's what Armstrong-Sappington also claim here. This policy might look like rather ideal in theory, but it seems rather impractical to implement. An example which I came up with, that telecom firms, for instance, might be exempt from regulation if they provide fiber access to the internet. Okay, they provide a much higher quality, and as a return, they get exemption from regulation, meaning that they can charge a higher price. Okay, after all, what is quality? You might impose a minimum quality standard. Just think of our slaughterhouses, where we have this discussion whether we should or could have some minimum quality standards. Of course, that would also be the minimum quality standard with the switching from consumers, from telecom companies. It could also be in terms of punctuality or whether you or equipment of your rolling stocks of train companies. Okay, that you have to have Wi-Fi in each train and so on. That would be minimum standards. The problem is that it's not always clear what quality is. Extreme case, and that's not from me, but from Armstrong Sapping, is TV programs. Our public broadcasting system is Musikantenstadel, so these kinds of very strange music shows, or is sports program, is broadcasting football really quality, okay? It's hard to control that by regulation. And the point is, as always, it's always nice to have competition, because if you're not satisfied with the service of one company, you just move, okay? And consumers can observe quality, and then they can tell whether they're satisfied with the service, even though they cannot really explain what this quality is. Okay, I think hopefully this was sufficiently clear. I think here it's in particular with all these kind of tariff basket regulations and all these wonderful diagrams and probably really confusing diagrams I had, like this one here. It's really important that we discuss all these concepts in detail in the assignment or in the tutorial class. You will see the assignment has many specific applications here, so that it should become clear. Okay, so yeah, as you saw, I already managed to get to the next chapter, which will then be the final lecture. I thank you for your participation this morning, and I'm available on Webex for some further questions and comments. And apart from that, I just thank you for being with me, and goodbye. Yeah, we are finished today. So about the quality of the sports broadcast, if you think of the German commentators in these public broadcasting stations, it's really a catastrophe, I think. Okay, anyway, for those of you who are not fans of football, just don't think about it. Okay, thank you, and see you in Webex and next week.